Now that we've talked about a tax on producers, let's think about whether we can change the impact that the tax has by putting the tax on consumers instead. This time, because consumers determine the demand side of our supply and demand model, we want to understand how a tax affects the demand curve. When we say that a tax is on consumers, we just mean that the consumers are the ones sending the checks to the government in this case. Though less common than a tax on producers, these sorts of taxes show up in excise taxes on cars, out-of-state sales tax that people are supposed to account for on their tax returns, and so on. In this case, we're going to consider the same 50-cent per unit tax as we did last time, but this time the tax is on the consumer. Let's say that this demand curve represents the customers of the small gas station that we introduced earlier. So again, we can think of this quantity as being in, let's say, gallons per day. And our tax amount is just a constant 50 cents per gallon of gasoline. The question we want to ask ourselves is, how does the consumer's willingness to pay for gasoline change when the tax is imposed? So we can think about some individual points on this curve to see what happens. Let's take one hypothetical point. Let's say at a price of $2.50, consumers are willing to buy 20,000 gallons of gasoline. What we mean by this is that consumers are willing to purchase 20,000 gallons of gasoline if the price, the total outlay for the consumer is $2.50. We're assuming here that they don't care how much of that is the tax and how much of that goes to the producer, but the total amount that they're willing to pay cannot exceed $2.50 if we're going to have 20,000 gallons purchased. So when we have this 50-cent tax in place, we can ask the question, well, what is the maximum amount that producers can get and still sell that 20,000 gallons of gasoline? You can just think about, well, if $2.50 is the maximum total outlay from the consumer, and 50 cents of that is going to the government, then $2 of that is going to the producer. We can mark that point, let's say here. And we can think about another point. Let's say we take a price of $1. And at a price of $1, consumers are willing to purchase 38,000 gallons of gasoline. Again, if the consumer's total outlay is going to be $1, how much of that is actually going to the producer? When we say 50 cents is going to the government, then 50 cents is left over to go to the consumer. We can label that point. So we say, in order for 38,000 gallons to be demanded by consumers, the producers have to keep a maximum of 50 cents per gallon. We can think of that point right here. We can do one more example. Let's say at a price of $3, consumers demand 14,000 gallons of gasoline. We can put that point up here. Again, if 50 cents of that is going to the government, $2.50 of that is left over for the producer. We can see that point is right here. Just like we did with the tax on producers, we can connect these points and notice that we're effectively shifting our demand curve. You'll notice, just based on the intuition of what we were doing here, that we're shifting our demand curve such that the vertical distance between this demand curve here and this shifted curve is the amount of the tax, namely 50 cents. So we can note that like this. Now, we call this the effective demand curve because it states the amount that consumers are willing to purchase is a function of the price that the producer gets to keep. If you remember from last time, we said that a regular demand curve is technically speaking a function of the total price that the consumer pays. Well, in order to be able to solve in our supply and demand model, we want to think about, well, what does that mean as a function of the price that the producer gets to keep? So simply put, this shifted demand curve, or this effective demand curve, is just what demand looks like as a function of the price that remains in the producer's pocket. What I've done here is I've drawn our original and our new effective demand curve along with a supply curve here so that we can analyze once again the impact that the tax has on the overall market. You'll notice here that the original price and quantity, P star and Q star, are just at the intersection of the original supply curve and the original demand curve. So now we want to think about when this tax is put in place, where is the new equilibrium? Well, we take advantage of the fact that we notice that supply is a function of the price that the producer gets to keep for the item, because the producers care only about their own profits. And our effective demand curve is also a function of the price that the producer gets to keep for the item. So it then makes sense that our new equilibrium is where those two curves intersect. So our new equilibrium is found at this point here. We can then say that our equilibrium quantity is just at this point here. We'll call this once again Q star sub T for tax. And then we can ask ourselves, what are the relevant prices in this case? Well, the obvious starting point, again, is the price that's at the intersection point here. So we can say, well, we want to label this as some sort of price. We just need to understand what that price represents. Well, we notice that both the supply curve and the effective demand curve are in terms of the price to the producer. So this price to the producer here, also called the supply price, shows that we've decreased from the original equilibrium price. The second question that we want to ask ourselves then is, where is the new price to the consumer? Well, if you recall, the consumer is paying both the amount that the producer gets to keep, and the consumer is also paying the amount of the tax. So we can go up from the producer's price by the amount of the tax to find the price to the consumer. And because of the way that we've drawn this, we know that the vertical distance between the effective demand curve and the original demand curve is in fact the amount of the tax. We know that when we go up vertically by the amount of the tax, we're going to hit the point on our original demand curve. So we can say here that the new price to the consumer, or the new demand price, is at this point here. Qualitatively, we can see that this is similar to what happened when we put a tax on producers. We notice that the price inclusive of the tax to the consumer is higher than it was before. We can see the price that the producer gets to keep net of the tax is lower than it was before. And we always want to remember that this original price is not necessarily right in the middle, and that we can determine the tax incidence on both the consumer and on the producer by how far the post-tax prices are deviating from the original equilibrium price. So for example, the per unit tax incidence on the consumer is just this P sub C star minus P star, and the per unit tax incidence on the producer is just this P star minus this P sub P star. You'll notice again that the distance between these two prices is the amount of the tax, And therefore, the combined tax incidence for the producer and consumer is 50 cents per unit. And again, we have the relationship that P sub C, what the consumer pays inclusive of the tax, is equal to what the producer gets to keep plus the amount that goes to the government. So if you ever get stuck about thinking which point is which, just remember that when you have a tax, the price to the consumer, just logically speaking, has to be higher than the price to the producer. So we can compare this to the situation where we had a tax on producers, and we can see qualitatively that we get to about the same outcome. We get a lower quantity when we put the tax in place. We see that the price to the consumer increases. We can see that the price to the producer decreases. The question then becomes, from a quantitative perspective, is the situation where we put the tax on consumers equivalent to that where we put the tax on producers? So now what we're going to do is we're going to go through an algebraic example equivalent to the first one to see if we get the same numerical answers.